Guys, today let's look at Lintcode problem number 117, jump game 2. Given any array of non-negative integers and you're initially positioned at the first index of the array, and each element in the array represents your maximum jump length at that position, and your goal is to reach the last index of the minimum number of the jumps. For example, you're given an array 2, 3, 1, 1, 4, and the minimum number of the jumps to reach to the last index is 2. Why is that? Because when you initially positioned at the first element, which is 2, you have the choices to jump 2 steps, and you choose to jump 1 steps, then you reach 3. And then you choose to jump 3 steps, 1, 2, 3, so you can just jump to the very end of the last index. So in this whole course, you just jumped twice. And of course, you can have some other options. You can, when you are at 3, you can jump 1, and you can jump another 1, and you can jump to the last index. So all in all, this question is to let us to find the last minimum number of the jumps. So we will definitely use DP, dynamic programming, to do this. And we already mentioned the jump game 1, so let's do a comparison to see what's the difference between them. For jump game 1, actually it's just access to answer the questions of feasibility if we can jump to the last index. So that's how we initialize the DP, and our definition of the DPI is that if we can reach to index or not. In jump game 2, not only do we have to answer feasibility or not, we have to answer the minimum jumps. So all in all, actually the whole algorithm framework is quite similar. Its only difference is the state transfer equation. So let's see how do we do it. This is the entrance jump. We're given an array, and first we check the parameters. Then we initialize the DP array, which is the same length size of the given array. So we initialize it to be system.max8. That means we cannot jump to each point. So that's the initialization. Initially we're positioned at 0, so the minimum length to jump to 0 is 0 because we don't have to jump. We're already in at 0. Then we use the for loop to calculate each DP element. We use the I to loop through this array, and then we need to calculate I. But it's so hard for us to to analyze the I and its adjacent states like I minus 1, I plus 1. So we're gonna just use the intermediate state J. So we're trying to figure out the I and the intermediate J, their relationships. So J starts from 0 and less than I. So it's a previous state of I. So we're going to just do an if here. If we can find a J, and AJ plus J's index greater than I, that means that starts from AJ, we can reach I. So that means that we may find a bridge point J. J can update DPI's value. From J jump to I, we just need to do the DPJ plus 1. But since DP, we just want to have the minimum number of jumps, so we have to do a minimum. Apply a minimum function to get the minimum one. So that's the for loop. Yeah, this is the core. So we just loop through all the elements. We loop through all its intermediate states, and we try to find the intermediate states that can jump from the source to this intermediate states and jump to the end, jump to the current index I. If we can find that one, then we try to update the DPI. Okay, so after this is done, we calculate all of the DP's value, and we just return DP last index, which is length A minus 1. Okay, so that's basically the whole algorithm. Let's just run this. It's great. Great, it's running, it's all green, so we passed all of the test cases. Come on. Okay, that's fine. Because we're using Python, and sometimes Python got issues with the time. But it's okay. Remember that if you use the DP, definitely you have to span n squares this time complexity. But it's okay. So basically speaking, this is all okay. You can just give out the solutions during the interviews. Actually, your interviewer want to see your DP solutions. So time complexity is not a issue. And actually, using DP usually it's n squared. Yeah, it's quite common. All right, okay, that's today's algorithm, and thanks, and I'll see you in next tutorials. And also, please subscribe. All right, bye.